Hey, fifth graders, today we're going to be talking about decimal place value, and we're going to be working on that math work that you were handed. It was a 6-question sheet that you should have gotten yesterday. If you did not get it, please make sure that you go back to the eClass page, and there's a button that you can click so you can take a look at it. If you haven't completed it already, that's okay. We can work through it together. So before we get started with that work, let's take a look at what we know so far about decimal place value. So taking a look here, we see thousands, hundreds, tens, ones, tenths, hundredths, and thousands. As you can see, I underlined the TH in these 3 boxes. This helps me remember that this is less than a whole, right? This is a tenth of a whole, a hundredth of a whole, and a thousandth of a whole. Another important thing to remember is that as we move left on this line, we know that the hundredths is 10 times more than the thousandths. The tenths is 10 times more than the hundredths. The ones are 10 times more than the tenths, and so on. This is going to be important to remember as we look through this first question. Another important thing to remember is that as we move this way on the chart, we go down, right? So this is 10 times less, or a tenth of the thousandths. This is a tenth. The tens is a tenth of the hundreds. The ones is a tenth of the tens. The tenths are obviously a tenth of the ones. The hundredths are a tenth of the tenths, and the thousandths are a tenth of the hundredths. So taking a look at this first question, let's go ahead and read. Miss Harview wrote the numbers 8,425 and 5,384 on the board for a class discussion on place value. Which answer explains the relationship between the value of the 8 in both numbers? Before I even take a look at these answers, I want to think about what this question is asking me. It's asking me to look for the relationship. So how do these compare? What makes them different? I also have to look at what number it's asking me to look at. And it's asking me to look at the 8. So when I look at both these numbers, I know that I'm focusing on this 8, which is in the thousands place here. And then I'm looking at this 8, which is in the tens place here. Well, if I go back to my chart and I write these numbers in, I see this. So I have 8,000, 4 hundreds, 2 tens, 5 ones, giving me 8,425. That's that first number right there. The next one is 5,384. And I see that here. Now what I want to do is I want to take a look at those 8s. And let's see what we can tell. Like why are they different? How much more is this one than this one? And how much less is this one than this one? Because we can tell this is less because we know the tens is less than the thousands, right? So if we look here, we can tell that we go 10 times to the hundreds and 10 times to the thousands. That means that this 8 here in 8,425 is 100 times more than this 8 in the 5,384. We also can tell, in vice versa, or in the opposite, that this 8 in the tens is 1/100th less than the 8 in the 8,425. So knowing that, and how did I get that 100? Well, 10 times 10 is 100. So that's what helped me get that. Looking here, I see that I have some answers. I see some with the fractions, meaning that they were moving backwards. And I see some with whole numbers, meaning that they were moving up. So the first thing is that we can tell that it's comparing the 8 in the 8,425. So it's asking me, it's saying how it's in all of the answers. It's saying, what does this compare to this, right? Well, I know that this number is 100 times the value of this number. So let's take a look if we have that answer here. The 8 in the 8,425 is 10 times the value. Well, if this was 10 times the value of this, it would be here, and it's not. It's all the way over here. The 8 in the 8,425 is 100 times the value of the 8 in the 5,384, and that seems right. 10 times and 10 times. That seems pretty right. Down here, I see these fractions, meaning that we would be moving this way, right? So this 8 would need to be over here or over here if we were comparing it to this. So looking here, this has to be the answer, B. Moving on to question 2. Let's talk about the ways that we write a decimal. There are 3 ways that we talked about. Actually, there's 4. We talked about modeling too, but for right now, let's talk about these 3. The first one is standard form, 456 and 987 thousandths. I can see that here, word form. It's written out in words. And then we have expanded form where we break apart the numbers and multiply them by their place value, right? We see the thousandths here, the 7. We know that the 7's right there. So looking here, we see we have this all broken apart for question 2. It says, what is the standard form? We know that standard form is just a regular old number. So looking here, we need to make this thing that's pulled apart, we need to put it back together, right, into a standard form, the basic regular old number that we're used to. So looking here, I see that we have an 8 in the 10,000s place. So I have an 8 here. I know that I have a 3 in the thousands place. Well, I have 10,000, then I go to 1,000, so I know that this number is next. From 1,000, I know that I go to 100, and I can tell this by making a chart on my own, right? So I can make a chart that looks like this. Okay, and I know that I have thousands, hundreds, tens, and ones. Then I have a decimal. I have tenths, I have hundredths, and I have thousandths. So I know that I have my 10,000s, right? And I'm going to put that here too. I forgot that that one was there. 10 thousandths, right? And I know I have an 8 there. I have a 3 here. I have a 9 in the hundreds place and a 1 in the tens place. And I have a 7 in the ones place. I have a 5 in the tenths place. I have a 2 in the hundreds place. And I have a 4 in the thousandths place. So now I can finish that number, right? 83917.524. Also known as 83,917 and 524 thousandths. Let's go on to the next one. Over the past week or so, we've also learned about rounding decimals, and I'm going to give you a reminder of what we learned. So when we round decimals, we find the place, right? So if it's asking us to round to the thousandths, then we need to look in the thousandths place. Once we look there, then we look next door. We figure out if that number next door is 5 or greater, then we'll add 1 more. If it's 4 or less in this one, then we'll just let it stay the same. All the digits in the front, so all these ones here, stay the same. But then if there's any numbers behind it, we turn those to 0, right? So let's take a look at what we have here. It says round 55 and 32 hundredths to the nearest tenth. Well, if I'm rounding to the nearest tenth, first thing that I need to do is take a look and find my tenth. Well, I know that my decimal it's going to be on the right side of my decimal. And I know that I start with tenths and then go to hundredths. So I'm going to underline tenths. So it's my 3 that I'm looking at. If I look next door, I see that we have a 2. That's less than 5. So my 3 is going to stay the same, but my 2 is going to turn into a 0 because I'm rounding. So it's going to be 55 and 3/10. Looking at this next one, you could also put a 0 there too. Looking at this next one, it says 12 and 488 thousandths. Well, if I'm going to round this to the nearest hundredth, I'm going to look for my hundredths place. I know it's on this side of the decimal. So I'm going to go tenths, hundredths. I'm going to underline it. I'm going to look next door at my thousandths place, and I see that it's an 8. That is 5 or higher. So I am going to turn this number into a 9, right? I'm just going to go up 1. So my answer becomes 12 and 49 hundredths. And I can add that 0 there too in its place. All right, let's take a look at the next question. Miss Berg bought school supplies at the store. She bought a notebook for $12.89, 3 pencils, and each cost $1.09, and 1 package of markers for $5.41. What is the best estimate of the total of these items before tax? So we talked a little bit about money and how it relates to decimals, right? So when we're thinking about rounding, we should probably round to the nearest whole number so we can figure out what's a close number to what we're going to spend, right? So she bought a notebook. I'm going to put the notebook here. And she bought it for $12.89. She bought 3 pencils, and each of them cost $1.09. So she bought a pencil, and a pencil. $1.09, $1.09, and $1.09. She also bought a package of markers. So I'm going to put markers here. And this was $5.41. Great. So now let's figure out how we could round these. If I'm rounding this one, I'm going to try to figure out what it's closer to. Is it closer to 12 or is it closer to 13? Well, if I look next door, I see an 8. So this is definitely closer to $13. When I look here, is it closer to 1 or is it closer to 2? Well, I look next door and I see a 0. So this is definitely closer to $1, right? $1.09 is closer to $1. So I'm going to put $1 here for each of those 3 pencils. And it's important that we remember that when we are reading. It said 3 pencils, not just 1. So we had to do all 3. Then we look here at the markers, and it's $5.41. If I'm rounding to the nearest dollar, I need to look next door. I see a 4. That's less than 5, so I'm going to stay the same. So this will be about $5, right? That's our estimate. So now what we need to do is add up these totals, and that's going to give us our total estimate for all those items. So I have 13 plus 1 is 14, plus 1 is 15, plus 1 is 16. Then I have 16 plus 5, which gives me 21. So my estimate is $21. And that was D. All right, let's take a look at this next question. And this is about the power of tens, which we love learning about. So let's take a look at this power of tens, right? When we look here, we talked about exponents, and we talked about how we are multiplying every time we have one up here, we're multiplying it by itself. So if we have a 0, then it just means nothing, right? It means that the product is 1. If we see 10 to the power of 1, we're just multiplying, it's just 10, because we can't multiply 10 times 10 until we get to the 2. So we multiply 10 2 times and get 100. So 10 to the power of 2 is 100. 10 to the power of 3 is 1,000, because 10 times 10 times 10, right? 3 times is 1,000. 10 to the power of 4 is 10 times 10 times 10 times 10, which is 10,000. So this is an important thing for us to remember. So looking here, it says Sean is working on different patterns found in her math problems. He begins by evaluating, I think this was supposed to say found in his math problems. He begins by evaluating the problems below. So he looks here and it says 458 thousandths times 10 to the power of 1 is 4 and 58 hundredths. Right here, it says 458 thousandths times 10 to the power of 2 is 45 and 8 tenths. Notice how that decimal keeps moving to the right as we increase by one exponent. Then we see 458 thousandths times 10 to the power of 3 is 458. It says, by what power of 10 would Sean multiply 458 thousandths to get a product of 4,580? To figure this out, first of all, I can write this number down, right? We can tell that this decimal would have to move how many places before it would turn into this number? Well, if we move here, here, and here, it turns into 458. Not quite. We need to move one more to add that next zero. And then here we are. So we moved that decimal 1, 2, 3, 4 times, which means that we would need to multiply 458 thousandths by 10 to the power 4 to get 4,580. So really what this question was asking was 458 thousandths times what equals 4,580. And we know that our answer is 10 to the power 4. All right, last question. Jonathan is 3 and 493 feet tall, 493 tenths feet tall. Matthew is 3 and 482 thousandths feet tall. It's like a tongue twister. Maya is 4 and 112 thousandths feet tall. And Ashley is 3 and 5 tenths feet tall. List the people in order from tallest to shortest. So for me to do this, I like to line up my numbers, right? So I'm going to line them up. Okay, so right here is where I am. I'm going to add in some zeros here so that all of these are the same, lined up. First things first, I'm going to start with this number, my ones. Well, instantly, I can tell that this must be the tallest person. So this person is Maya. I'm going to put Maya right here. Maya, and I'll cross it out, make sure that I remember. Okay, so I've looked at this, the ones place. Maya was 4 feet tall, and the rest of them are 3 and some change. So Maya is the tallest because she has that extra on them. So let's move on to the next one. Well, the next tallest one is, it's hard to tell from just these ones. So we need to move on to the next little area. Well, right here, I see that we have 2 4s and a 5. Well, the 5 is bigger than the 4s. So this person would be the next tallest. And that was Ashley. So I'm going to put Ashley here. Cross that out. I'll cross out Ashley so I don't forget. Now I look here, let's find the next tallest. Well, I have 4s here, so I need to move over to my hundredths. Notice how I'm working from left to right. So I move over here. I see that there's a 9 and an 8. My 9 is bigger, so this person is taller than this person. So if I look over here, who has 3 and 493 thousandths? That's Jonathan. So Jonathan is the next tallest. I'm going to cross that out. And it seems as though we only have one left, and that is Matthew. So Matthew is the shortest. And we know that because the 8 is smaller than the 9. And we cross that out. Awesome. So what you guys are going to do for your assignment today is you are going to create your own problem. Think about the questions that we've had. Maybe you can make a problem about writing a decimal. Maybe you can make a problem about powers of 10, or maybe you can make a problem about rounding decimals. It's up to you what you want to do. Come up with your problem, solve it, and then be ready to show your teacher tomorrow. I hope you guys have a great rest of your digital learning day, and we will see you tomorrow.